Howdy, howdy. I'm Carlos, and I work on artificial general intelligence from a Popperian perspective. And every week I get together with some friends to talk about that, as well as the broader knowledge based view of the world that comes from Karl Popper and David Deutsch. This week we talk about measures of progress, local optima, and how neural networks and evolution avoid them, different forms of universality like Turing completeness. We also talk about potential limitations on what happens in human brains within the skull. Can we visualize in 23 dimensions? What would it take to be able to do that? We talk about intelligence in a world where there are patterns in the world versus a world where hypothetically there were no patterns. It was pure chaos. We talk about what has to be built into a mind from its very inception rather than what can be learned. We also kind of dig into some fiction, such as there is no antimimetics division, where they have memory erasing entities. And we ask questions like, how do you fight such things? And then we also finish up on Infohazards and knowledge which would potentially destroy you. And what are the countermeasures against such things? Are there always countermeasures even in existence? But with that, please enjoy the conversation.
I've been writing a lot, okay? Can't say that my thoughts have been very clear or making any progress, but this is a part of the process of making progress.
Cool. Yeah, I mean, there's like, if I wanted to round that up to my nearest talking point, I'd say that, the measurable progress or progress which is measurable in a way that most people would recognize as progress is obviously something that happens only after a lot of other stuff has happened, most of which it would not be recognized by them as progress. And so,
Right.
on your way to writing your famous paper, if you're Einstein, before you wrote that paper and had the right equations, you had all the wrong ones. And so people would say that isn't itself useful, though they might hopefully recognize that the activity of working on it was. And if you only demanded, as evolution does, that every step along the way was better, you would be, you can make progress that way. But it is much, much harder to get to certain kinds of points. It may be impossible
Well,
to reach certain kinds of things.
doesn't evolution also run into dead ends, and then those dead ends will be literally dead?
With evolution, there's obviously some species go extinct. Although even then, their genes may live on in other species. And Dawkins makes the point that looking at evolution as sort of a tree of species is a very high level perspective. And in fact, it's more like this river of genes. And the genes may go on in, a much more reliable way that far outlasts any particular species. So like the genes in your mitochondria, or let's say, those are spread across many species. Even if your particular kind of genome is never seen on the face of the earth again. But yeah, so there's that, and there's also the idea that like setting aside maybe the dead ends, there's a separate question in this book, Arrival of the Fittest, which kind of goes into this idea of neutral mutations and their value in terms of allowing you to reach what may well, I guess the reason I bring it up is because it says that it's hard to reach a dead end in evolution in the sense of a particular genome where you can reach no other genomes that are better. Because there are so many small changes that do nothing to change the phenotype, so that they're just neutral. But because there are so many of these neutral mutations, you can often reach other better hills to climb. So in fact, these local minima that are literally minima, that there's no neutral path elsewhere, that's actually pretty rare. And I almost like to think of it like that the main thing that evolution does, the main thing that it works on is genes that make proteins. And a lot of these proteins that are made, they aren't like really minimally designed, elegant computers or machines. They're like balls of mud that have approximately the right sort of shape. And so there's lots of ways you can twist up the proteins that would make that vague shape that is correct. And so you can change a lot of the internal bits around, and eventually you can change them around in such a way that maybe they can fold in quite a different and other useful way. And so if you're trying to make a protein that is shaped like a ball, there's like a billion ways to make a ball. So there's a lot of room for tinkering in the internal structure of that ball that allows you to reach other shapes. But anyway, local minima that are like really strict dead ends are apparently quite rare in sort of that space of genes and phenotypes. But yeah, that's just a talking point for me. I don't know if that addresses kind of where your head was at.
Makes me think of like neural networks. It's why gradient descent works so well, is because in super high dimensional spaces, local minima or maxima are very rare. At worst, you tend to end up with saddle points.
Nice. And hopefully there's no local minima for any of the work that I'm writing and the work that we're doing. Hopefully it never gets to like this complete dead end. It can always improve.
Yeah, I wonder if it's possible to end up in a dead end in the human mind. I mean, I guess that would entail an end of error correction in some sense. And so you have to have some pretty bad ideas to get you to that point where you can't say like, go back to school for 4 years. Like, like even if you devote half your life or all of it to some wrong idea, you can go back and retrain and do other things. So it's only if like you're on the edge of survival and any unexpected change would kill you, or something about the way you think doesn't let you rethink anything, that you would have that kind of problem, which is pretty rare and extreme in the West, that you probably only see in like somebody who ends up in prison because they're just so wrong-headed about something, or they would lose their business because they can't cope with the changes. So it's pretty hard to maintain super rigidity in a society that's changing. Like you would probably notice such a person. Yeah. By the way, I was talking with a friend recently about Deutsch's idea of hard to vary. And one thing that came up in that discussion that I thought was kind of interesting that I hadn't thought about before is that, I often return to the idea and wonder, like, how would you make this idea computable or computational or more concrete? And for anybody listening to this who hasn't heard that idea, the idea is like some theories are very easy to change, and if you were to prove one of them wrong, you could change it easily. And maybe you would think to yourself that you're making it better. You have some myth that God did it, but what if you say Jehovah did it or some Vishnu did it? You can just switch out different elements, but it doesn't really matter. And so it doesn't. If you're thinking in that way, where you can just swap out arbitrary bits of your theory, it doesn't really help you get any nearer the truth, even though you are sort of looking at one of them, testing it, showing it to be wrong, moving on to the next one. This is, in some sense, you're making progress. You're showing certain ideas that you had before to be wrong, but you're operating in the search space, which is so poor. Vishnu did it. No, God did it. No, Hermes did it. These are things you could try to check, but there's an infinity of such things, or at least a large number. So it's not a very fruitful type of search to do. You want to kind of escape to a different level of thinking. You want to approach the ideas differently. And so if Einstein makes his theory, it's actually quite a different structure to it. And if he's wrong, he doesn't have that many places to go. But he's working in a space of theories that is much more fruitful to think about. But anyway, that set of ideas has always been a little bit vague. And so how do you make it more computable and that kind of thing? And I think one of the things that's interesting is that if you can kind of take a different line of thought, got me thinking about that idea differently, which was, here's a tangent. It's that, are good ideas rarer than bad ideas? In the usual sense that we think about it, yes, they're much rarer. And most ideas suck. 90% of everything is trash, and yet if you take the idea seriously that there are an infinity of ideas out there to be discovered, then, and you divide them, let's say, into good and bad ideas. Well, there's an infinity of both. So, and one infinity is the same size as the other, if they're both sort of, in the set of countable infinity, whatever. So if you just take the statement literally, then you can't say that there are more good ideas than bad ones if there are infinite numbers of both. And that could seem a little bit like angels dancing on the head of a pin, because it's like, still, we kind of know, like, yeah, the good ideas are rare in the sense that matters. So must not be a sense that matters. But I think it's kind of an interesting idea that sort of says, well, you can't measure quantities of ideas in that naive way. You have to say like, okay, well, if good ideas are rare in a different sense, then what is that sense? And this is where this line of thinking kind of converges on the hard to vary thing, because the key part of that phrase is vary. Hard to make changes to. And when you start talking about changes, you can ask which changes, because given some idea in the space of ideas, you could make a change to it that would turn it into any of the other ideas in that infinite space. But of course, most of those are unreachable to you at a given moment. You can't just go from Newton to Einstein. Nobody knew how to make that particular change at that time. It took a bunch of other things along the way, such that that change was eventually a few ideas away, and Einstein could grab it. So what actually matters here when you're sort of measuring quantities of ideas or talking about these kinds of things is asking what specific steps of change are we considering? And if there's a certain number of those, well, now you have a set of ideas you're considering, which is finite, because you sort of start with some ideas you know, and you have some ways of changing them. And that set of changed ideas is now the ones we're considering. And in that set, the original idea and all the changed ideas of that one, all its sort of, all the mutated versions, all the child ideas. Okay, now in that set, if an idea is really good and hard to vary, like Einstein's was, well, then all of those child ideas are going to be horrible. And those specifically. There will be an infinity of yet better ideas that no one has thought of and no one will be able to think of in the next year. There's going to be, from Newton's perspective, Einstein is out there and Einstein plus plus ad infinitum, perhaps. So that's all out there, but that's not for you right now. You have your ideas and the 1,000 that you generated based on changing all the numbers around and reordering your current theory and all that stuff. And then the question is, okay, we have an idea, we have all these variants. If we look at this set, is it hard or easy to vary? Are they all equally good? In which case your original idea was no better than the others? Or is that original idea actually really a lot better than the others? In which case, okay, it's hard to vary. It is better than all of the specific variants you could come up with right now. So anyway, I thought that was kind of an interesting line of thought that was kind of just starting from this idea that in some sense, good ideas are rare, but not in that pure mathematical sense, if you take it super literally. So it drives you to come up with a more, I think, precise notion of which sets are we measuring here to talk about the, relative quantity of good ideas versus bad ones.
This comes a
Spiel
little bit.
complete.
This comes a bit into one of the things I've talked about a couple times of thinking that categorizing alternatives is an important part of problem solving. So to say that something is easy to vary is to categorize a set of different alternatives, an infinite set of alternatives, and say that they're all the same because you've categorized them all the same to dismiss them all. But you need some pretty sophisticated criteria sometimes to determine what set of theories are all the same so that they can all be dismissed, or so that you can say that they're all easy to vary and can be looked past.
That reminds me of another element of the discussion I was having, which was one of the reasons that this hard to vary idea is supposed to, what is the cash value of it, one might ask. And it's that you should be trying to find those because that's a better way to find good ideas. But that leaves open the question of, well, how do you go about doing that? Like, if you're in a situation right now where you have an answer or you have some question and you can only come up with bad answers at the moment, like you don't have a good answer. How do you go from that situation that is, let's say, all your answers are shitty and easy to vary and they're all, you have a bunch of shitty possible answers. How do you go from that to one where you have a really good idea that is much better than all the alternatives? Well, what does that look like? And so I think it's not a general thing, but one thing you can talk about is kind of like this idea of categorization. Like you have a bunch of theories at like one level of analysis, but then maybe a good answer doesn't even exist at that level of analysis. Mm-hmm. Like if you're trying to explain why people act a certain way, like there may be like no particularly good explanation in terms of atoms at all. Like you have to go to a different level of explanation to kind of see what's going on, because in the future, if people don't, like your bodies aren't even made of atoms, let's say, well, then your atomic level explanation won't cover that other hardware that the human mind is running on. This is kind of, I guess, a sci-fi example or whatever, but you can imagine quite similar things. Like, suppose that actually, thermodynamics is talking about energy, and you can make really sharp statements about energy. But imagine you could only talk about energy in the context of molecules rather than something else, or only metals versus some other thing. Well, really, there's a very high-level general truth to be had about energy. But if you're only limiting yourself to like one particular instance of it in a particular type of material, then you're not going to really be capturing this more general truth. And it may be very difficult to specify a really deep idea there. So one element of like how you go from this situation where things are easy to vary and crappy to one where they're hard to vary and good might involve sort of changing your domain of analysis to something where you can make sharp statements, whereas your current domain you can't. But anyway, that's part of that idea.
I've had a version of this conversation with someone where it's basically the same thing of like, hey, Deutsch has this thing about hard to vary ideas or explanations. And then it's like, okay, how would I implement this? And the part that I got stuck on was like, the second part of that statement is like, oh, ideas that are hard to vary or explanations that are hard to vary while still purporting to explain the thing that they're trying to explain. And I think it wasn't clear basically like, what is the algorithmic way you could decide whether the explanation has been spoiled by changing this detail or not? Like, if you like, there's a implicit claim when you talk about, Vishnu did it or Zeus did it or whatever, that kind of explanation where you're like, okay, changing that variable doesn't impact the quality of the explanation. Whereas if, say, we're talking about the seasons, which is the classical example, and you say like, oh, the Earth's orbit is tilted or not tilted, then that totally spoils the explanation because, but like that, like everyone, like a human being can recognize that, but it's not clear that a computer program would recognize that. And so it basically came down to like this, the person I was talking to was saying like, okay, there's something to do with like these things that they would call causal links, where you can't establish a causal link between the god doing a certain thing in seasons, but you can establish a causal link between like the tilt of the Earth's orbit and seasons. But even I'm not super convinced by this, because even then you're just kind of like, there's no good definition for what it means for something to have a causal link or not, right? And yeah, so I was also basically in the same situation of like, okay, well, yeah, how would I implement this thing of hard to vary on a computer?
I feel like tied to it is the idea that it also has things it can't explain. You know, God did it can explain just about anything, whereas there are observations that, the tilt could not explain. If if the seasons were the same in both the northern and the southern hemispheres, the tilt of the Earth wouldn't explain it.
There's something specific to be said about explanations, but the idea of something being hard to vary is actually more general than that, because a hammer is hard to vary in a certain sense as an object, in terms of, it's superior to other objects for its purpose. So I think there's a separate conversation maybe to be had about, hey, if we're talking specifically about explanatory knowledge, what kind of criteria are we looking for there? But it may be quite different in other domains. And I think the more general point, as far as what I was taking from Ali's point, was something like, if you switch the metric, if you switch how you're assessing things, then something may be hard to vary or easy to vary. So I think if you were to put several objects on a table and you were to say, hey, I'm interested in something being a good hammer, then you would put out, a brick there, you would put a hammer and some other things, and you would say this hammer is hard to vary, is vastly superior to the brick in its ergonomics and ability to hit the nail. You'd say, cool. But then again, if you're only interested in a paperweight, then all the objects are equally good if they're the same mass or whatever. So suddenly Yeah. So this illustrates the point that hard to vary means, I guess it's like saying not just about while meeting certain explanatory criteria, but it's like I have a certain metric. The goal of any metric, by the way, is to distinguish between different things. And you switch out that metric, you're going to get a different ordering of which ones are better or worse.
Right. That's interesting. I like the tool analogy where, yeah, a hammer is just as good as, say, like a MacBook if you're talking about a paperweight. But if you're talking about a computer, then a MacBook is way better. Um, but yeah, I guess anyway, the thing that I I'm still thinking about is like, yeah, it's you're kind of depending on the other person to just kind of agree with you when you say that, look, the um, tilted Earth explanation for seasons is harder to vary than the um, Zeus is using his thunderbolts to do it explanation. Because, like, I don't know. Okay, I'm not explaining this well, but like the I don't see a way to like programmatically confirm that it indeed is a better explanation. You just kind of have to rely on the fact that it does actually make more sense. But yeah, anyway, I don't know if you guys, if this resonates what I'm getting at.
Well, on that point, there's like two separate issues again here. On the one hand, there's hard to vary and that kind of thing, which is really just saying how much better is this thing than the other things that I'm looking at. That's all it really is. So you have a bunch of things, and you have some way of comparing them, and then you're asking, is there a standout? Or are these all equally good, or many that are equally good? So I guess another way to put that is like, is this like a fitness peak or a plateau? Is there any particular reason that I should prefer this one to all these other ones? And so that's just the general thing. So there's 10 things and they're all equally good, not hard to vary. If there's one of them that's special, then okay, hard to vary. So that's that thing. And then as far as like, hey, if you're Einstein, how do you tell which theory is whatever is better? That's a kind of a separate issue, which is more like, hey, I have this human thought. I don't know how the hell I would encode that in a machine, which is the same position that somebody who can distinguish between two different birds or look at faces would have had years ago, where they're like, I can do this, but I don't know how to get a machine to do this. And that's just a generic problem of knowledge representation. Like, I know this, I don't know how I know it, I don't know how I'd encode it, but that's a somewhat separate issue, which is itself very interesting because it kind of ties into this idea that, like, on the one hand, one thing that's very important about a mind that can think very flexibly is that it has Turing completeness and can think anything. But then but just because you have the guaranteed ability to create a program that could represent anything doesn't mean you know how the hell to make a particular program that does the particular thing you want. It could be arbitrarily hard to do that. And if you have a mind with like the equivalent of a bad programming language, it will in general be very difficult to express anything worthwhile in that very crappy language, including how theories work, what theories are good, so on.
Mm-hmm.
I think there's another part of the hard to vary. Well, it's more just about categorization. So if you categorize the implications of Zeus did it versus the implications of Krishna did it versus the implications of Vishnu did it versus the implications of Jehovah did it, they all have the same implications, which is one way to categorize them as all being the same theory. And then you could test one of them, and then that is enough to dismiss all of them. Whereas you have the opposite, you have the other theory of the tilt of the axis of the Earth. It has different implications than all of those, and you can test those, and then you have that one as a preferred theory for the reasoning of the seasons. So I think it's just about this categorization. And there are different reasons to categorize things and different ways to do it, but one of them is to see that the implications of all these different variants of that theory are all the same, so you can just...
But I would disagree that they're all the same, because like if you think Vishnu did it and you know other things about Vishnu that differ from Zeus, then you're going to be more afraid of this versus lightning or something or the other. So they may agree in some ways, but then they differ in others. And so their implications aren't the same, though they may be the same in a particular area that you're looking at. Like they both
Right.
offer the same prediction of the seasons, but then
Yes.
differ in every other way. And I think my favorite illustration of this kind of thing is like showing curve fits of like a particular stretch of data. So you see a bunch of points, and on those points, you make a curve fit, and you can make 20 curve fits that all agree within that range, but then all disagree outside that range. And so you looking at this system can now look at it and say, which one of these curve fits should I trust outside that range, given they all disagree outside that range, but agree on everything that's known? So what other criteria can I bring to bear that would help me distinguish between these 10 different theories? Let's say for the moment that one of them is right. How do I know which one? And so in general, I tend to think about this in the context of what are the limits of data? And is there any amount of data that could get you out of this situation? Or is it always the case that however broad your distribution of data is, it always has an end? It's always finite. So there's always going to be out of distribution stuff, no matter how big your distribution and your sample is. So do you need something different, something more rule-like, something like conservation of energy, which would say, hey, you have 10 different functions, and as far as the data is concerned, they're all good. However, this formula, this idea fits this rule. The others do not. Therefore, you can eliminate them and keep this one curve that otherwise, if you only had the data, wouldn't have looked special. It wouldn't have looked better. But anyway, addressing your point there that you can have many ideas which have the same implications, but that's only in the range that you kind of know about. Outside that range, they disagree.
Right. It's for the problem that you're attempting to solve. So yeah, that's a fair nuance to have there. But again, I think it's important to have a specific way to categorize alternatives and consider them to be the same or different or related. And the criteria for doing that should be open-ended. So you should be able to have new ways of categorizing things or new ways of determining if things are different.
Yeah, like the idea that things are the same or different is itself like super interesting. Because I think I've said this before. One reason that I like epistemology is that it does seem to like centralize and unify a lot of things. And so if you were working in one industry versus another, you might both be measuring things at various times and not realize that every industry who's making anything needs to measure their products along the way and make sure they fit the design. In this case, there is a field called metrology, the science of measurement. So in that particular case, it's well known, this similarity across fields, and anybody who needs to measure anything knows about that field and that they can talk to somebody from another field and learn how they do it. But I think more generally, there's this need to anytime you're doing anything, you're going to have mistakes along the way and need to do error correction. And there's no escape from that, no matter your industry. I think that's a case, unlike metrology, where there's not a clear field for learning about that. There's general business practices, this and that. But the idea of epistemology and philosophy of science and connecting all of that together, I think that's a much less clear thing. So in terms of categories, what's similar, what's different, if you know epistemology, you'll see similarities across these fields that you would otherwise be blind to. But that's ditto for everything else. If you see one sheep versus one frog, the notion of one is something which you'll see as similar if you have notions of number, otherwise not. Within any given domain of analysis, it sort of gives you a lens on the world. And you kind of take all these pixels, which are all, but by the way, every pixel screen that you look at is always different. So if you take this idea really seriously of similarities and differences, it's actually pretty fundamental, because if you operated at the level of pixels and screens of pixels, every single screen you ever saw in your entire life, every nanosecond or every millisecond, would be different. And if you saw them all as different, you would be cataloging information about each screen and be totally blind to the fact that, hey, when I see a lion out there, that's kind of one thing. And I should have a set of knowledge about that one thing, not just focus on that particular pixels. That's a horrible representation of knowledge, a horrible failure to recognize patterns in reality.
Mm-hmm. There's another weird thing that happens. Well, I mean, it seems kind of obvious to us, but the idea that Newtonian mechanics and Einstein mechanics are rivals and they both solve the same problems. That's pretty sophisticated. That's like really high level. Like I don't even know again about computers, like programming this. How would you have your computer programmatically determine that these two theories are attempting to solve the same problem and that they should be considered rivals to each other? That type of thing seems, I mean, because on the face of it, they are very, very different theories.
Yeah. I mean, I guess we have all the usual things you could think about. Like, do they help you with planets and things like that? Or and like, do they help you with cosmology? So there's a certain set of, there's like an ensemble of problems to do with how the planets move and, what happens on Earth when you drop things. And any theory that makes statements about that, or both of them, ideally, you kind of view as this one kind of thing. But yeah, before at some point in history, people didn't recognize the similarity between celestial mechanics and terrestrial mechanics, and would have thought of those as separate problems and books that should be separate. But then the notion of that problem changed, and that was a leap.
Yeah.
Yeah. One thing I've been thinking about recently also has been I've been like revisiting my ideas on like universality.
Mhm.
This is something where there's like a whole chapter in the beginning of Infinity about this, and I just listened to that yesterday. And because I often go back to this idea that AGI, artificial general intelligence, is is distinguished by its ability to like think anything, and the anything is the key part of that. Not some things, not arbitrarily many things, but anything. So getting clear on what that actually entails is super interesting, and that's why I've talked before about like Turing completeness or different things like that, or Popper completeness. So I've just been kind of revisiting my ideas there and thinking about that. So I wonder if you guys have, if that's been bouncing around your mind at all. I have some thoughts on it.
And when you say think anything, do you mean specifically that it could generate any thought or that it can have like any thought? Because I'm guessing a Turing machine could have any thought or you can like input anything into it. But
There was a good quote in the chapter, by the way, where again it gets at that difference between a system which can be programmed to think anything versus one which itself can, generate stuff. And Deutsch makes a point that only people can rely on themselves into the indefinite future. That was kind of the way he phrased it, which was to say that if you have some other system like a computer, it can compute anything, but it's still like it's going to run out of memory. It's going to run out of energy. Things are going to break. It relies on all these external sources of maintenance and so on and inputs in order to really be universal. And if you remove those things, it stops being universal. It runs down after a finite time. So if you were to look at it, you'd have to say the thing itself, as physically formed in our universe, like it's this pretty limited thing that will run down. However, and that's true not only of computers but of other things. I forget what all he goes into, but so all those things sort of require help from the outside, except people. People, if you look at them as sort of a system, it's not a closed system. Like often you want to go out into the universe and gather resources and that kind of thing. But still, the thing that is causing all this stuff to happen is being driven by what's in the human mind. It's the thing causing all that stuff. You don't need God to come down and give you the resources and help you. So I think that's this unique thing. We sort of have all the stuff that we need to figure out solutions to our problems. But yeah, so that's part of this broader question about what is it like once you raise the idea that universality and this sort of kind of completeness is an important thing, there enters this question, what kind matters? Because it's not at all clear. Yeah.
I wonder if you arbitrarily restricted one possible thing, let's just say we have a hypothetical device that could generate any thought and run any program except one program. Does that make it not, does that completely destroy its functionality or does that do anything? Does it have any like negative impact on its abilities?
Yeah, it's a fun kind of question to think about. Yeah, like in the strict sense, you'd say, okay, it's not universal. Like
Right.
completeness means complete. Yeah, if it's not incomplete in any way, then that's not good enough. In my case, I'll usually be thinking of that in the sense of saying like, oh, is it infinite? Because infinite sounds good, but infinite doesn't mean complete.
Hmm.
Infinite can be there can be a little gap in there somewhere, or it could be an infinite gap. Like, you can't think of odd numbers. You can think of
Right.
all the even numbers, and there's an infinity of those. So be happy with that. But obviously, despite your infinite reach of numbers you can think about, there's all these other numbers that are quite useful that you can't think about. So that'd be a limitation. Um, Another kind of thing you could think about, yeah. So purely from a definition perspective, if there's anything you can't think, then you're not universal. I think in practice, probably the question would be, if you produced a limitation of that kind, would you actually be able to be so specific in what you limited the system to do? Like, would you actually be only omitting one capability, or like a whole swath of them that you thought you were only doing one little pinprick, but actually you like hobbled the system horribly? Uh, is it so clear? I don't know.
Yeah. Interesting.
Also makes me think about, like the different infinities. Uh, could it run any program almost surely? Which means generally in mathematics, there are maybe particular programs that can't run, but they have measure zero. Uh, so you could get arbitrarily close to that program.
Hmm.
And like if you sample the space, you will never find them because they're so specific.
Say more. Is this something like from a computability theory, or
This is it's something in probability theory.
okay?
Uh, like you can say something is almost surely true if it has probability one of being true, or I guess measure one of being true. Um, so there can be like individual points in an uncountable set where it's not true. Uh, but if you sample that space, you will never find them because a single point in uncountable set has probability zero of being sampled.
Hmm. I guess that's like
And
the. Sorry, go ahead.
so I'm thinking of this like if programs are continuous and it's like exactly one program cannot be run, you can maybe get arbitrarily close. So in any sort of meaningful sense, you can run essentially that program.
That said, you have to distinguish between like the structure of a thing, sort of the genotype phenotype thing, like the structure of it versus its consequences. Because like if you're saying it's the same, almost the same structure, it could have wildly different behavior. Uh, but yeah, I
Uh,
guess that's true of like comparing like the any given countable set of numbers, like the integers to the reals or something. It's like you would sample and you would never hit an integer. Uh, so there's like there are zero
I was
integers in the yeah.
I was thinking of what Zachary said, and I feel like it's almost paradoxical because it's like, um, let's say the thing that came to my mind was like, let's say you make AGI, you might ban the command like rm-rf slash, which for computer non-computer people, it basically is like delete everything. Um, but yeah, and you can still keep everything else. So if you wanted to, you could one by one delete every single file. So you could still delete everything. It's just like this one particular command is banned. But then as I thought about it more, I was like, hey, well, then the system, assuming everything else is available, could employ creativity to figure out how to overcome this banning and bypass the kind of firewall and go and do it. And if you assume kind of unlimited growth and progress, then it's a no go. So if it's actually kind of a cool way to think about it, it's like yeah, there's probably a bunch of things humans can't think because of the way our brains wired, like can't think temporarily, right? Like because of the way the brain's wired, the brain size, chemicals, all sorts of things are probably like keeping some things like we forget stuff all the time. But yeah, all those things we can use creativity to fix up so then we can reach that leftover space of the idea space. But yeah,
I like that.
I feel like also thinking about this, like a human cannot imagine an object in a 23-dimensional space.
Mhm.
But on the other
yeah,
hand, we can create mathematics that can deal with those and define their properties. And so, maybe we can't have exactly the thought of picture a 23-dimensional hypercube, but
yeah.
we can hack around it to essentially manage that task, even though we can't say do it directly.
Yeah.
Yeah, I think that's an interesting case where it pays to think, and well, I guess it raises the question of what significance should we attach to the skull as the limit of what humans are up to? Um, because yeah, if something is happening on the paper or in some other tool, is it like, okay, well, we can't technically do this, but we can kind of do it this other way, or should we think of that almost like, you know, if that thing wouldn't have existed but for humans, then humans did it. And so the question is only, did humans do it or not? And in the case of producing some kind of like, how many dimensions did you mention in your example?
I think I said 23.
Let's go with 23 then. So if you're asking like, hey, there's this certain kind of representation of a 23 dimensional space, that like if you have this representation, then you can play catch and you can do things like that, like the way humans can in 3D space. So like in 3D, we can intuitively assess distances, we can do trajectories, we can see somebody throw a ball and catch it, roughly speaking, and do specific operations on objects in that space. So you could say, hey, what would it take to produce an analogous thing for 23 dimensions? And can humans bring such a thing about and make those calculations and whatever? And the answer is obviously yes. And it happens not to reside in the skull. And that can be annoying, but I guess ultimately maybe it doesn't matter that much. And I think eventually, in the sort of transhuman kind of thing, we'll be able to bring that into the skull. Because I guess there are kind of differences there. Like there are things where you can very well. I was going to say, like, it's nice when something is in the skull because it can kind of form all these rich associations. And, like, in your head, you can imagine arbitrary 3D scenes combining all kinds of 3D objects. And it would just be kind of onerous at this point to do the same with 23-dimensional space. You have to be like, I have to open up my computer. Already, I'm annoyed at the fact I had this extra step involved. And then I have to like go to a website with 23-dimensional shapes and I have to click and drag those into the thing and whatever. And so it's this more lengthy thing. But even then, with Claude Code these days and everything else, who knows, maybe that gap of annoyance of computer use for us will get narrower and narrower. And then maybe eventually it will be in our skulls, or maybe that representation will never be in our skulls, but it won't matter because the software is so good, we don't even notice.
Mhm. Is there are there hard limits to the efficiency that you can get with certain types of processes? It's a weird thing to say, but like perhaps we can imagine a four-dimensional thing. Like, I mean, I guess I could imagine something four-dimensional, but it'd be inefficient and difficult to do. Does that mean that do I have the ability to arbitrarily efficiently be able to imagine four-dimensional things and then, of course, going up to the 23-dimensional objects and spaces?
So I got some thoughts here. Isn't, aside from speed and memory concerns, isn't it only a matter of efficiency? So if it's possible for a 23-dimensional object to be pictured, then we can do it, excluding speed and memory. So it's like if we can't picture it, then it can't be pictured, period, right? Because we can picture anything that can be pictured because of universality. So the skull size and nothing matters, again, excluding memory and speed. Maybe you need a minimum amount, a certain amount of memory, and well, it would only be memory to picture a 23-dimensional object. But as I think Deutsch and others have said, we're probably not close to limited by memory. We don't use even, close to how much we have. So I like thinking of it that way. Like, if there is such a thing as picturing a high dimensional object, then we can learn to do it, excluding memory.
Yeah, the question in these cases is what kind of change is required. In some cases, you can just learn an algorithm for adding numbers and multiplying numbers, and it's a simple enough algorithm with a small enough number of steps. You can recall the steps and execute them relatively reliably. But then when it comes to like doing longer calculations like pi, suddenly it takes a guy 20 years of continuous work to produce an error-ridden calculation of pi, as historically was the case. So there's going to be things that are easier to reach than others in the space of all ideas. And so it comes down to this efficiency and sort of reliability of grasping this object in the space of ideas. So one kind of question is, maybe it's possible to make anything in that space arbitrarily reliable and easy. However, certain steps are required along the way, and you can ask, what are those steps? And I think that's kind of where the practical question comes in for anybody like who exists at this particular moment in history with its technology is this a look at a YouTube video for 10 minutes and then I got it? Or is this a wait 100 years for nanotech and then I got it? Even if you assume that it's possible to do it, obviously those are practically different situations.
So discussing like efficiency and complexity is the only thing that gets us away from hard numbers like 100 years, 200 years, 1,000 years. It seems to me we wouldn't want to be talking about things in terms of human-centric timelines. So isn't the whole defining quality of personhood that it is a program that can evolve any other program tractably, like specifically tractably? That's sort of what I've arrived at. Is it's a question of, it can navigate in the space of possible ideas without slipping into like exponential time, because then, there's no amount of time in the universe but it shouldn't even be dependent on like lifetime of the universe. That still might just be some arbitrary finite number of years. So it seems to me like it's completely a question of the efficiency of synthesizing programs. So that's sort of the direction I'm going in.
But the space is infinite, so it can be arbitrarily far away, even for the most efficient searcher.
Yeah, that is true. I guess but there's sort of like a memory horizon, which makes it finite, right? So only, I guess no, that's still infinite. So with a finite amount of memory and speed, is it still an infinite space of programs? I guess it is.
Well, the space of the space itself is independent of any particular system for searching it. So, like, even if there were never any humans, there would still be this question of what is computable in the universe.
Yeah. Oh, yeah, but it's not about everything that's computable in principle, but so a person is a system that can synthesize any program within its speed and memory, domain, and it can do that tractably. Maybe that's the definition. I just think it has to do with, as we've established, being able to think any thought is not a definition, because any computer can think any thought. It's specifically about being able to develop thoughts, evolve thoughts. So I'm trying to figure out how to sort of formalize that.
Well, I think one thing to do that's helpful is to focus perhaps less on a particular system or talk about a definition of personhood, though those are interesting in themselves. You can sort of take the reverse direction, which is ask first what the universe allows in terms of computation and other things. Can you build a black hole, whatever. And then say, okay, so there's this set of possibilities. There's a set of possible ideas. Now, one question is, how can you navigate that space? Because there are some universes, some conceivable realities in which everything that was possible, all the space of ideas and everything, was just totally chaotic and random. Like, there was no efficient search path because what happens next is there is no pattern to it. Reality is chaos. There is nothing to be learned that you could say, I now understand that when you give a dog a bone, it barks and does this. Like, there's because in that reality, you could give a dog a bone, and like next thing that happens is a supernova. Like, there is no
Yeah.
if this then that kind of thing. So we don't live in that universe, and therefore there are patterns in reality. And then the question becomes, okay, what kinds of patterns are there, and what kinds of systems can identify and exploit those patterns? Because really, the ability to efficiently search and exploit reality depends on there being patterns, and you being able to discover and exploit them. So I think that's the core thing. And so that Deutsch as a tangent here will sometimes talk about like modes of explanation, and I think that's another way of saying types of patterns in reality. Some things are a pattern like such and such cannot exist. Okay, that's a certain kind of pattern in reality. A different kind of pattern might be like, hey, this is proportional to that. It's a different kind of pattern. And so there are all kinds of patterns in reality. And the most powerful kind of system would be capable of discovering and exploiting any such pattern, no matter how complex or whatever.
Yeah. Yeah, I don't take issue with any of that. I think that's all well said and true. So anyway, yeah, I guess it's about so the system can work at arbitrary degrees of abstraction, I guess is one thing that jumps out to me. Yeah, I don't know. I'd love to just nail down some kind of definition, but I guess that's the whole problem.
Yeah.
Something that's interesting when we're talking about like visualizing in higher dimensions, but let's take vector spaces. I'm reading this book right now called Why Machines Learn, which is about like the history of machine learning. And we've known about vector spaces for at least like 200 years, and like higher than three-dimensional vector spaces. So the point I'm trying to make is like there's been this incentive to visualize these vector spaces because it would help a lot, at least with this machine learning stuff. Um, but no one seems to have figured it out yet. I would think that if there was a way to reliably visualize even just one extra dimension, this would be like a totally like an intro class in machine learning of like you sit down, you close your eyes, and then someone guides you through some kind of exercise where you try to think about like a higher dimensional vector space, and you're able to visualize it. Even if it had some like horrible success rate, I think it would be so worth it that we would do it. But anyway, but the point I'm making is that no, we just really it's something about either the human brain or we don't know the right program. It's just really difficult to visualize higher dimensions. But that hasn't stopped us from doing a bunch of machine learning and math around it because we just take a different mathematical approach where you just try and break it down into things about like the area of a circle if you assume you have four numbers instead of three numbers or two numbers to define points, and you just kind of get these mathematical results. But it's almost entirely that kind of approach that has worked as opposed to like, hey, visualize this type of thing in your head. So anyway, it's just interesting, right? Despite this incentive, it hasn't worked.
Is there a major difference, I'm wondering, between computing something and displaying the results of the computation? I do remember in The Fabric of Reality, David Deutsch talks about computers, virtual reality, needing a computer, and then separately needing a device that connects to your senses. But that extra device that connects to your senses is not necessary, or it's not a fundamental aspect of the computer. So I'm saying all that to say that the actual visualization is kind of a display of the information, but you could just have the information mathematically, and that totally counts the same as a computation of that object in that higher dimension.
Yeah, so I think there's a difference between running a program that manipulates objects in these higher dimensions where we've done quite a bit of that kind of programming.
Mhm.
But there is always this thing that machine learning people at least will talk about of like that it really sucks that we can't visualize Like you can't think about it in your head. You have to go and write the program. Um,
If
yeah.
you could visualize it, there are probably shortcuts you could take where you can
Yeah.
see
Or insights. Yeah.
consequences in a single step that would take you many steps to derive working
Yeah.
mathematically.
Yeah. Like one concrete example is seeing clusters of points. If you plot points in 2D, you can just see, oh, there's a cluster over here, there's a cluster over here. You can also do that in 3D, but then in 4D, you're kind of out of luck. So you have to do a whole bunch of these like dimensionality reduction things. Anyway.
Actually,
Yeah, that makes
interesting, this
sense.
idea. You actually, in some sense, can't do that in 3D, in the sense that if you're seeing 2D, certain
Yeah.
parts are
Yeah.
hidden. So already
Yeah.
there are some fundamental
Yes.
constraints there, uh, in as much as you're working with 2D data while imagining 3D
Yes.
situations. Um, but you could already imagine, I guess, in a different world where you actually are operating natively on three-dimensional objects, which I guess you
Right.
maybe have a little
Exactly.
bit more of that. I guess that is what we tend to operate on in our minds, but never in, through our
Yes.
eyes.
Hmm.
So,
Yes.
yeah.
Yeah, precisely. When you plot stuff in 3D, usually you make a video of it like rotating, or you just rotate it with your mouse, and that's where the 3D comes from. But yeah, at the end of the day, it's all screens.
I guess I say that, but then, yeah, well, I was gonna say when you operate on when you hold something in your hands, that's 3D, which is kind of
Yeah,
true.
you
But
could
then you're
3D
still
print it.
seeing 2D always.
Yeah,
Um,
yeah,
But your imagination could just be the feeling along with the sight. Your imagination is not only limited to visuals, so
yeah,
you
yeah,
can see and feel it and have multiple
yeah.
dimensions in that
Your
sense.
sense as you navigate a space is often 3D, and if it
But
wasn't, then you would crash into things. And
Right.
with stereo vision, you still have some aspect of 3D.
Hmm.
You know, you can't see the back, but you can map depth of the surface facing you.
but that's only 2D still in terms of the actual data. But yeah, you're saying I want to operate on 3D things, even though I'm only taking in 2D things. But I am taking in two of them, which helps making the 3D thing. But you never take in 3D. Um, although unless you talk about time again, but that's a different thing.
Yeah.
2D images over time, and then you're making your 3D thing. It is interesting in kind of making it a little bit more precise, because I don't tend to think about that. That's another case again of maybe of why we like visualizations of that kind, because it is actually somewhat transparent to us and hidden that we are only seeing 2D at all times, because it's so immediate that we experience the 3D. And wouldn't that be nice if you could have that for 2070? But alas, it's not quite
yeah,
so transparent.
Then maybe you could with a brain computer interface. Um, you know, we can only visualize 3D because we live in this 3D world. Um, and we only ever get 2 plus 1D sensory input. Uh, but if you had an artificial sense fed by a computer, perhaps your brain could learn to interpret that. And then after doing that, you could visualize in your head um,
Yeah.
that the problem is we don't have any sensory system to compare it to. And so if you could find a way to generate a higher dimensional sensory system with the right sensor wired to your brain, you might be able to learn to do it.
Well, one thing I think is interesting as a thought experiment is asking almost like a computer scientist about like the resource requirements for doing like 3D versus 10D versus 100,000D computations. Because even the same algorithm of like distance calculations would require something analogous or something proportional to like the number of dimensions involved, and maybe square of that in some cases. So you could ask the question like, how big would your brain have to be in order to like rotate an object in 3D versus 100D? And I don't know the answer, but imagine that it said you would actually need a brain the size of 10 people or a continent well, then clearly, though something would be conceptually the same as what you're doing now, just calculating a distance, you'd say, well, until you have access to a planet-sized computer, in some cases, you're not going to have that intuitive. You're not going to be able to do that computation at all, first of all. But then B, you would need sort of that planet-sized computer in the loop with your other thinking in order for that to be transparent to you and to be able to think about that in the same way that you do with this simpler, smaller computation. Because in the case of a computer scientist or programmer, often they don't care about the 2D versus 3D versus 10D, as long as the computer is fast enough to handle all of the above within a second. You don't realize, like, oh, this computation required running a huge cluster in the other side of the country. But that's just a computational detail under the hood. All you did is say, I have this data set, I want this answer. And you got it pretty quick. So that the size becomes a very small implementation detail. So I could see that happening. But it'd be funny because, you're like having to connect yourself up to some huge computer to make it happen seamlessly.
Galaxy brain, we can get there one day.
Yeah.
I've got back to a little bit about the idea of what's necessary for AGI. Of course, I think being able to have any thought, being able to generate any thought, being able to make any program, being able to run any program. I also personally, I break it down into different steps of being able to notice any problems, which is like a specialized type of program, and the process of having that program or the criteria for that program should be able to be open-ended. So there's finding problems, of course, generating a program, guessing a solution to that problem, categorizing those problems. I say that a lot. And then that all of the criteria for all of those should be open-ended, then selecting the problems, and then determining if you had progress after you've selected the right program. Those are all like specialized programs, I think, that would be necessary for solving any problem.
Yeah, I think novelty generation, as I always say, and metrics for comparison, and all these things are relevant. One thing that I've been thinking that is sort of related to this, but a little bit different, is that a few weeks ago I kind of made a similar list of here's a set of things I think we need for AGI, and I'll call that proper completeness. You can do this, you can do that, you can do that. And then there was this question of, I think you asked it, like, is that enough? Like, do other machines that exist right now, do they have that? Mm-hmm. And it just got me thinking, like, is that enough or is it not? Again, my list was something like you want to be able to compute anything, generate any program to be computed. You want to use anything that you have come up with for the purpose of making new ideas and for the purpose of assessing ideas' value and that sort of thing.
I asked specifically, is there a way to make a shitty version of proper completeness? Attention.
Nice. Is this from like your notes from that day?
Yeah, I've got my notes. But I'm kind of losing.
Well, I'm impressed with your notes setup. You got everything good to go.
Yeah, I was just on Google Docs.
Yeah. Excellent. But so there is that question of whether you could make a shitty version. Do we already have such a shitty version? What would that look like? Is it enough? And if you made such a version, would it be AGI or is it sort of lacking some stuff? So so that got me thinking, what else? What else would you want? And that's actually kind of true for universality in general. Like, you can say, is universality enough for some situation? But in this case, it has me thinking about, on the one hand, the ability to think anything. That's one kind of sort of thing. But then there's also this question of where you start. And is that important? And maybe also what kind of theories you have built in when you're born. What kind of programming language of the mind you start off with. That might make a big difference as to what is easily thinkable versus what is hard to think. In the same way that we talked about with dimensions. Like, imagine if it was just super hard for you to think in 3 dimensions. That would obviously be a limitation. in practice. Even if in a billion years you could overcome it, you'd ideally want to start off with a good setup. So yeah, I have been thinking about that a little bit. Yeah, everything beyond universality that would help.
Do you think there is a necessary starting point?
I don't know. With neural networks, it seems like quite random initializations often work. So there isn't necessarily a super sensitive, a great sensitivity to where you start. Although I think some initial conditions might not be good. One kind of question is if you need to have certain kinds of things built into your mind, what would they be? Presume like maybe they wouldn't be about specific physics stuff. Maybe it would be more like understanding that the world consists of objects and their relationships. Like if your brain is set up to make that kind of thinking really easily, really easy, maybe that is actually a really important thing. Some people in machine learning like to call that sort of built-in thing like an inductive bias. I would object to the term inductive, but anyway. But they would call it something like that. Basically, built-in background knowledge that the system has from the start that it didn't learn. You've biased it from the beginning. Another thing might be more epistemological. Like, what if the system is built in such a way that not only can it think of new ideas and judge them, but it is built in such a way that those things are fundamental and super fast and easy. So it's almost like an epistemological bias from the start. Because, for instance, let's say you need memory that is very fast, and you can come up with quick short-term memory for trying things, and you have longer-term storage memory for saving things. That's useful for a lot of reasons, but maybe for that ability to try things and keep what works. So you could ask the question, okay, I want a mind that can think anything, can generate anything, blah, blah, blah. But not only that, I want a brain that has additional functionality that makes those things super, super frictionless. So that not only can they happen, but they do happen a lot. So that would then go beyond this idea of proper completeness of just, you can do these things, but you have additional structure that makes them fast and easy. And that's a different question. That may require a whole different setup. Maybe you want to have, a system like the brain that's very associative, has these different types of memory, other things like that. So that might mean that you could have a shitty version of proper completeness where those things are possible, but almost never happen. So to make it a better version, you need to make them easy.
Interesting. Yeah. It kind of goes back to what we were saying earlier about the local minima and can we get to a dead end in the mind, right? If we can get to a dead end in the mind, that means that there are some starting points that really are really, really bad. But if it's not possible to get to a dead end, then you could really start anywhere. It's just some of them will be less efficient. There's another thing from David Deutsch. He mentions that if you had a mind trapped in a chess program, would you still be able to understand the laws of physics or generate the laws of physics? And he comes to the conclusion that you could, no matter your starting point, no matter how wrong your laws of physics are based on, the things that you are able to generate in virtual reality, you could still create the correct laws of physics.
In that case, I think it was a slightly related point, which was maybe more about would you be cut off from reality and unable to discover things, or would you be able to discover that you were in some kind of fake reality or only a small part of reality? So it might be that you can't discover what reality is really like while you're stuck in the chess simulation, but you can still recognize that you are in sort of this ideological prison, and that so you would then form the idea of wanting to escape it. And it might be arbitrarily hard to escape it, and so maybe you never do. But you could at least recognize that there was this. You would recognize some of the structure around you. That I am at least knowing that this isn't everything, and so
Right.
that's a pretty strong bit of cosmology within that sort of chess world. I'm looking at something, and I know there's stuff beyond that. There has to be, whereas before you didn't know that. So you can at least get to that point.
Yeah. And then the idea is, I think that we are currently in this position because we are limited to our senses. So we have an incorrect virtual reality of the laws of physics. And even given the incorrect laws of physics, only access to the incorrect laws, we can create the correct laws. Or
I
at least
don't
we
think
can.
that's quite true. I think like one general thing about coming up with the right theory is you kind of have to have the right, uh, the right theory is out there in the space of ideas, and it's quite hard to hit upon it. So you kind of need some pretty specific problems to guide you to that spot. And if you are kind of too far away from them in the space of ideas, it's going to be hard to hit upon that. You're going to have to set up your lab, and you're going to have to start asking the right kinds of questions.
Right. But we can crawl towards,
Yeah,
the
you can get
idea.
there. But I think the thought experiment I was thinking of as you were kind of talking there was imagine that you are currently stuck in the chess program, in that little simulation. Well, as long as you are stuck in that system, it's going to be hard to discover what the real physics are. Not that you can't escape it and eventually discover things. But yeah, while you're in there, it's going to be tough.
Right.
Yeah. I was going to say something else. I forget what it was. Yeah. By the way, Ryan and Tyler, feel free to jump in as much as you want. Uh, I'm just going through my notes here to see if anything else I wanted to talk about.
I was just reminded of anthropic reasoning and how, it's easy to think. We've been talking about how you could derive reality if you were trapped in a chess program, and people might say that, reality seems so finely tuned and all that, you know, and then we would say that, well, only the realities that allow for people would be like that, would be understandable and derivable. But then I remember Deutsch criticizing anthropic reasoning when it comes to like the space of all possible universes, all possible laws of physics, and how I think he was saying like, well, the explanation that we would only be in the ones, the laws of physics that allow for people, that doesn't, that's insufficient. So I've been wanting to understand that better and understand why it's insufficient, if anyone can explain that.
Insufficient for what?
Like it doesn't explain, that doesn't actually explain why we're here, why we're in this reality and not any of the other infinite possible. Even, I mean, there may also be infinitely possible, laws of physics, sets of laws of physics, which do allow for people. So there's still the question, why are we in this one with these physical constants and not one of the others? So something we said previously reminded me of that, but I don't know if that's too far afield.
So if I'm remembering right, I think it's that like in this multiverse view, there are a much larger number of sort of universes where we could exist very temporarily but be unstable. And there is a finite possibility of exactly ourself being created by a quantum fluctuation. Uh, and so uh, in this kind of probability measure, we should be outnumbered by people with brains like ours who have come into existence fully formed by a random quantum chance, asking, why is the universe like this? And then instantly disappearing.
Yeah.
And so because there are more of those than there are actual people like us, um, that's I think is his argument against this anthropic principle, that it's just that we happen to be the ones in or that only the people who ask that question are in places fine-tuned to them.
Yeah.
Right. And then he says if, our universe should collapse in 1 second or 2 seconds or 3 seconds, and it hasn't. So it's refuted as easy to vary. And
Yeah. I wonder if that's actually refuting it, though. I mean, because that could be happening. We just wouldn't know about it. Maybe the vast majority of all but one possible next instant are happening and we explode in all of them, but we wouldn't know about those. We would only be the one that isn't doing that. So I don't know. I'm not really feeling the refutation.
But I think it's just that it's easy to vary, and
Uh-huh.
since we can't really base our reality on that theory and the alternative theory, which is that we are actually in reality and it's not constantly being
Yeah.
destroyed, that has implications that are actually helpful and lead to progress.
Hmm.
So
Well, one kind
that
of
one's
question is
better.
that, all right, when you have this thing where you're saying like, hey, things went perfectly as far as we can see, like we're in the universe that works, or you do a magic trick and, I guessed the right card here. You're in some cases, like the magician just tried this a bunch of times. There's no trick to it. They just guess. So in order to explain how they guessed correctly, you have to refer to all the ones where they just guessed and got it wrong. And, but you need like a particular theory of all the other things that they tried. So I guess that's kind of another question here is that if you want to appeal to the idea that like ours went right because there's a bunch of other ones that existed that went wrong, you need to have some explanation of all those too. I haven't thought about this cosmological angle on things very much, but I know that's at least part of the critique of that sort of thinking.
So the point is, it doesn't work as an explanation. I don't really see why it's hard to vary, although I'm not saying it isn't, or why it's easy to vary. But the point is, we have to explain all the universes where everything explodes, and we can't do that. Or can we not do that by
I think
just
you have to
saying,
specify which other things happen, maybe.
uh,
It is like the
okay.
part that says only people who can ask that question are in the good universes. Um, because the argument is that actually there are far more of them in the almost good universes where they disappear almost instantly.
Hmm.
So the question, why are we in the good universe, isn't answered because that's the only place where we are.
Right.
Uh, because actually, it's according to this view, there are more of us in bad universes for very short time periods.
Yeah. But
And
still, I guess I feel like both are true. It's sort of it's a meta multiverse or a metaverse or a multi-multiverse, and that I don't know, that the experience would be the one thread of um, of multiverses, I guess, through that where there is consciousness happening. But yeah, I don't know. Anyway,
Yeah.
just to say the very part is that the universe is going to explode in 1 second from now, and also 5 seconds from now, and also
mhm.
30 seconds from now, and then also 10 seconds from yesterday. You
Yeah,
all of those
the time is
variations are the same. Yeah,
the
they
time
all
is easy to
happen.
vary. But what if
Right.
the explanation is at all times the universe is exploding?
So well, that's a good sentence. It
Not
sounds like a
aside
good.
from the one we're in.
I feel like also we don't have a good theory of like a meta multiverse, like with this quantum many worlds interpretation. We have this multiverse of all with a single set of laws of physics, and all the different possibilities that could happen in the different universes. Whereas we don't yet have any kind of theory of uh, a collection of universes with different laws of physics.
Right. I was also imagining that if the like different laws of physics is causing everything to collapse instantly, but if the laws change from one instant to the next, then everything explodes and we lose experience. But that may not even be true. It might just, there's a whole host of other infinite possibilities. It's not binary,
I
so it
I
doesn't work.
know there's some kind of I think it might be quantum Darwinism. There's this idea that universes are born in or on the edges of black holes. Uh, and those ones that are created similarly to the one uh, that they were born from. And so uh, the ones that have black holes create more universes. The ones of those that have black holes create more universes. So there are far more universes that can support black holes because they reproduce.
Hmm.
Hmm.
And
Yeah.
those the similar universes are like slightly different fundamental constants or something like that.
Yeah.
Hmm.
On a separate note, this reminds me of this book I was reading. There is no antimimetics division. It was popular on Twitter a while back, and uh, at one point it comes up that there's things out there that'll like eat your memories, and also like you're trying to fight them, and as you're fighting them, like you lose temporarily, and you also forget that you were fighting them. So, and then like 20 years later, you discover like, oh shit, there's this bad thing we have to fight, and then you realize later we were fighting it, and then it like beat us, and then we forgot about it for like 50 years. And this is
There's
and
a
then they
plot
ask,
of
how
that in
many
Doctor
times has
Who.
this happened?
Hmm.
What was that?
There was a plot like that in Doctor Who. There's like these aliens where people can't remember them as soon as they leave their field of vision. Um, and part of it, the main characters have figured this out, and they're making marks on their body whenever they see one. And then like something happens, and then it cuts to them. There's like just marks all over their body that they've made with marker.
That's cool. Like
Uh,
Memento.
in that one, the solution is they trick one of the aliens into saying something like, uh, you know, they're like, "You humans are stupid. You should kill us all on sight, but you can't remember it, so you don't." Uh, and they splice that clip into like everything, and no one actually remembers it, but like their brain remembers it as soon as they see the aliens, and so everyone kills the aliens, and no one remembers what that they did.
Hmm.
That happens in another book where I think who was it? But yeah, there's some guy who like murders somebody and then clears his memory of it, and then later I was on trial and he's like, I don't remember doing that, but all the evidence points against me. So isn't that a shame? Gets put in prison. Yeah, he gets. I think he gets like his. I think in this time in the future they can just like freeze you or like for like 100 years or something, or remove you from even having a body for that time, or something crazy. But it's like, or they kill you in such a way that like in this universe, when you get killed, you can be regrown from your backup, but it takes a while. So I think the person he killed, that's what happened to them. They're like, I remember I got killed, but like the last part of my memory of who did it got wiped, and this and that. And I'm alive now, but it's a pretty traumatic experience, even though you got to be rebirthed, and it took a couple years for that to happen. Some interesting sci-fi around there. I feel like that's one of the things that's kind of interesting when when one is interested in artificial general intelligence. I feel like that kind of sci-fi is fun to ponder about, and especially the part of that is looking at like futures where things are cool. But then I think the more creative writers can look at futures that have these interesting problems. Like, oh yeah, if you could try to kill somebody, what happens then? Uh, you know, Greg
It
Egan
also
by
makes me
himself as
think
an
of
author will look at some that are really very far future AGI situations where everything works smoothly, and the fact that they're AGIs isn't that relevant. Like the AGI part is not ever the problem, and then other ones that are more near future where like creating the AGIs and having them work properly is actually it's a little bit glitchy.
out of Lovecraft and the idea of forbidden knowledge that our brains can't handle. Oh, he was not a Popperian.
I
That's
mean,
right.
there's a lot of knowledge out there that will destroy you, like communism.
True.
So that's actually one thing that I like to think about. In addition to the, when it comes to being a good AGI or a good thinker, this involves more than just being more efficient than a system like biological evolution. Yes, we can navigate the space of ideas more efficiently, but also we have an additional quality which allows us to not only set aside an idea because it's a waste of time, but also because it's a danger and a risk. Like if you're working on jet fuel and propulsion, like it's quite important that you kind of like take your idea of like I could combine these two chemicals to produce a reaction and only use that in certain situations, like when you're safe. Because if you just did that anywhere, I wake up in the morning and I'm just going to combine these two chemicals and blow up your own house. You have knowledge in your head that will kill you if used improperly. So being able to make proper use of when and where to make use of your knowledge is a very important thing. And
This
that's, yeah, true
brings
in
up
general.
I don't know, maybe a philosophical question. Does or can there exist, destroyed knowledge that isn't solved by more knowledge?
Hmm.
You know, communism, uh, you know,
Well, this
the
comes up.
knowledge of it can be cured by knowing why it's bad, and
Hmm.
the risks of chemical reactions can uh, be mitigated by understanding them and knowing more about them and how it can happen. They're
Yes.
absolutely forbidden knowledge.
Yeah, it's not the knowledge alone, it's the running of the knowledge, right? You have to run the program. It's not like you learn communism and immediately explode. Uh, so yeah, I wonder about that. If there is knowledge that is, you just learn it and it's immediately a bad thing.
Well, in that case, I think there's this question that ties into the idea of like generalization or something. Like if there's a particular idea that will kill you for some reason, one question you can ask uh, is there any way that you could discover the existence of such a thing and
Mhm.
be careful about it? And we'll assume in this universe that there is some kind of countermeasure or whatever, some situation that would make it not dangerous. Um, but you would have to know what that is. And let's say that if you confront this idea before having the countermeasure, then it destroys you. So one question is, in what situations will you run into the countermeasure? Is it likely that you'll run into it before you run into the danger? Um, and how easy is it to discover the danger of the thing? If the danger is like chemical explosions, then as soon as you sort of understand chemistry and how energy is released, for any reason, and there are many reasons you might happen upon chemistry and that kind of thing, then that would give you this far-ranging knowledge, including of the danger of this other thing that you hadn't ever seen specifically. So I think that's kind of why it's a little bit implausible, maybe, why there would be a thing that like you could never, assuming there was a countermeasure, that you could never discover it, because knowledge is interconnected, and there isn't going to be this probably this single idiosyncratic danger that nothing else in the universe that you could learn would warn you about.
Probably.
And maybe to the extent that it was like that, that would mean it was quite disconnected from anything else, and therefore probably unlikely to be discovered doing anything else. Like if it's this thing where you have to produce this arbitrary string of digits that's a trillion digits long, or arbitrarily long thing that is totally irrelevant to everything, but it happens to be the case that if you made it, it would kill you. I don't think I doubt such a thing could exist because it would be very powerful, and I think that powerful things tend to be connected to other things. So I think it would loom large in how the world works. Um, but suppose it didn't, then you probably wouldn't bump into it anyway.
True.
So I think the likelihood that you will bump into it is also proportional to the likelihood that you would bump into its countermeasure, because it's the danger is something related to widespread phenomena, which you could learn about in many ways.
Could you say more about this? Powerful things are connected to other things, more likely to be, or
Almost by definition, I guess, really. Like, knowledge of how chemical reactions work is powerful because it applies to many situations. And,
hmm.
knowledge of knitting we may think of as less powerful because it's not so useful in that many places. So I guess there are alternative things which might be powerful but not have a wide reach, or not be connected to other things. I struggled to think of an example, maybe.
Right. So we're thinking powerful in this case of like depth or like generalizability,
Like it will
maybe,
kill
or
you for sure. Like it will have a strong effect. Um,
But
But I
like
think, yeah,
things that can kill me are not all like deep knowledge. A knife can, I guess a knife
yeah,
is pretty deep, but you can just die from slipping and falling, and that's not extremely like wide-reaching, particularly fundamental knowledge.
true. So you're walking along on this mountain, and there happens to just be this very deep hole, and it only exists right there, and whatever. Uh, however, in that case, that's not a great example because you have knowledge of gravity and the fact that you want to watch where you step and that kind of thing.
Mhm.
So you wouldn't probably fall for a normal looking hole. So it'd have to be like it looks normal from the outside, but actually there's like only 1 millimeter of rock there. You step on it and then you fall and die. Um, but if that's ever happened to anybody else and that started to happen more often, then you would develop countermeasures and you'd have a little goggles that show you how deep the rock is, maybe.
Mhm.
Yeah, I guess it's this idea that it's unavoidable once you gain the knowledge of it, is what means it has to be powerful. Whereas most of the things uh, that can kill you that aren't deeply connected are because you don't know about them. Uh, the things that are easily avoided once you have a little bit more knowledge.
Yeah. So what do you think of that idea that if it's yeah, I haven't thought about this before, but I think it's interesting and it plays with this idea of reach and so on and what things are connected to what. Uh, I don't know if I've quite gotten the spirit of what you were saying, or if I've kind of danced around it in some easier variant. What do you think?
Yeah, I think so. I mean, I only just thought of it.
Yeah, I
More as
guess
an
Doomers like to
interesting
think of.
question to ponder than looking for an actual answer.
Mhm.
Yeah, I guess yeah, it is a sort of kind of abstract question that is interesting. I think it does kind of tie into, at least in spirit, that idea of starting with how the world works and like there are conceivable universes where there was no pattern to be exploited, and so there's no sense of efficient search that's possible because there's just no opportunity to discover and exploit patterns. So I think that's kind of an interesting abstract concern that kind of it puts minds in a certain kind of light. It's like no mind helps you in a universe of chaos. So this shows you what the task of the mind is just to exploit these patterns. And so thinking at that level of okay, there are patterns in reality. So that's interesting itself, and you can ask almost like regions on a map. Like there are bigger countries and smaller countries and weird shapes. There's different kinds of patterns to that map and the countries on it. And so kind of now we're thinking about a more, we're thinking at a similar level, which is like, okay, there's these patterns in reality such that if you step into one of these countries, you kind of understand how that country works. So if there's a danger within that thing, you'll kind of spot it. It'll show up on your map. So we're considering a situation where, hey, there's a danger, but somehow it's not on any map. Um, and how might that work? Yeah. Well, cool. Any other thoughts? Anything else on your guys' mind, or shall we wrap it up there?
Let's wrap it up.
Wrap it up. Well, cool. Been
Yeah,
fun chatting, everybody.
yeah, fun chatting. Thanks.
Yeah, always a pleasure.
Cool. Adios.
See ya.